this class. So
Yeah.
Can we start recording? Okay.
I started recording. Yeah.
You have started?
Yes, I have.
Okay. Okay. So what we'll do today is that uh, we are going to cover two parts to the class today. One is that for the eighth class, we need to understand that for the eighth for the class on the eighth, we need to understand that there are couple of things that are expected. One is that all plans are expected to be detailed in the manner that has been already shown to you. Yeah, that is by way of so to say, that is by way of all the lettering, all the schedules. Yeah, all the most important, all the internal wall dimensions, all the levels, all the schedules. Yeah, the door window lecture that has been covered specifically for you to design door windows appropriately. Yeah, what is also expected is a reflected false ceiling and catwalk plan. I will be coming to that in some time of how catwalks are to be designed. Let me tell you that in the reflected ceiling and catwalk plan, it is important that you show where your light points, how your catwalk and your light points coincide with each other. Yeah. So suppose I draw a plan. Just let me give you a couple of guidelines on the basis of which you would expect a catwalk plan, and what kind of electricals are expected in that. So I'll just draw some things out for you to understand better. So if that's your stage area, yeah, it is expected that no catwalk happens over the stage area. Usually you see either a dog-legged stairs at one corner, or a spiral staircase in any one of the corners, allowing you to connect above the stage area. Usually you can walk above the stage area, sides of the stage area, not above the stage area, particularly such that because the stage area has mics and is pretty sensitive to noise. So usually you do not walk above the stage area, but there is usually a grid. There's usually a metal grid above the stage area held on with the help of the catwalk. So what you see here is the grid, and this grid allows you to drop mics. Yeah, this grid allows you to drop mics. So if I have to draw this section here, okay, that's your stage, that's your slope, whatever that is there. Yeah, and if your catwalk is yeah. So if your catwalk is somewhere there, yeah. So your catwalk, if it is somewhere, I don't know how to lock this. Does anybody know how to lock this? Would anybody know how to lock the screen?
No, Jimmy, is it happening like last time it was happening? Like that's why we started doing it in Paint, I guess, since it was moving with the touch.
Why does it move? Why does it not lock? How does one? So that's your stage. That's the catwalk around it. Usually, this catwalk allows you to drop mics along the grid on the top of the auditorium. It also is connected to a staircase either at one of the ends, either a dog-legged staircase. Make sure your metal staircase does not hamper people running at the backstage area. Yeah, preferably. Can you all see my screen, the new screen that I've opened?
No.
No, Jimmy.
No.
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 It's whiteboard. The drawing
Okay.
which you.
Lecture 1 and the plan and the line.
I think I'll have to. Yeah.
Now is the paint and the grid you
Yeah.
made.
Yeah. So what I'm trying to say is that make sure that your staircase connecting to the catwalk is in a manner whereby people can run around the backstage area, your whatever green room areas. See that it doesn't pose a hindrance. That's why most of the time, usually you have a spiral staircase or something like that. Okay. Usually so you have a catwalk that happens at that area in some sense that could be preferably your stage, okay, and the seating that goes in that sense, that catwalk, and then but naturally the lower ends of the catwalk allow you to attach the catwalks allow you to attach light, and these are the grids. This is the grid that I'm talking out in case you want to drop mics or stuff like that, or attach mics that are there. All that is possible because of this grid out here. Yeah. Then so the catwalk in some sense will have railings at its side. Okay. You need to decide how the catwalk is connected. Most of the time the catwalk goes and connects to the sides, preferably where your columns could be there. So if your columns are somewhere here or here, yeah, any of the columns that are there, then you will want to, and the depth of the catwalk actually acts as a beam. So this entire thing acts like a beam in some sense that is there. Yeah, as the false ceiling rises up in some sense, so does the catwalk also go up. So the catwalk in some sense becomes, in certain areas becomes quite steep by way of steps that are there, and then but naturally it goes, yeah, it further gets, yeah. So it's literally like a girder suspended below your existing girder. However, in plan, the catwalk will remain only in the areas where you actually expect to have the lights. So suppose you have lights here, yeah, your catwalk will be in a manner whereby you can walk along the catwalk and change these lights. So if I'm here, I should be in a position to stretch out my hands and change these lights that may be there. Yeah, if I'm there. Okay. So you place the catwalks preferably only where your light positions are, and no sooner than later, as you must have seen, the portfolio is going to expect you to have an electrical layout. So do not have the catwalk anywhere and everywhere. Have the catwalk only based on the kind of lights you have. Suppose your lights are all focused towards the corners. Then make sure that your catwalk is there only in the corner and does not run along the center. Yeah. So make sure that you have limited catwalks, maximum 2 to 3. Yeah. Suppose you have lights in the center, you may have a catwalk that is there in the center. If there are stairs, then make sure that your stairs reflect. Yeah. And then, but naturally, if your false ceiling panels that are there, then all those false ceiling panels will reflect in the reflected ceiling plan. So in the reflected ceiling plan, you will see a plan such as this that will show the positions of the catwalk, that will show the positions of the panels. Yeah, whether you would like to have fragmented panels or straight panels that are there. And more important of all, you will have to decide how you have suspended your catwalk. Yeah, so from the roof, how the catwalk works. Yeah, and what height you want to have above the stage area is completely in your purview. So this can all merge at that height that is there. And then, but naturally from this height, you may have another beam and yeah, and this area may limit to people coming in, and then, but naturally this kind of a cross section works like that. So this plan, reflected false ceiling plan along with the catwalk, is one thing that is expected from you along with a good roof plan. Now what is expected in a roof plan is, yeah, so if I have to reduce this, so if I have to put a roof plan on top of this, then but naturally what will be expected in the roof plan is whether you have any kinds of ridges, valleys, and what is the kind of levels that are there. So what is the level that is expected at this ridge point? What is the levels that is expected at those edges that are there, these levels? Yeah. And what kind of slopes do you have? Yeah. And how do you expect the rainwater to get off? Yeah. Because a big roof like that, the rainwater that comes down is going to create a lot of impact. Yeah. You need to understand how you divert that water. Most important of all, I hope you all now know that no sooner than later you will have to have a ground floor plan with all levels, all kinds of services that are there. Should time permit today, and should we go beyond what we intend to discuss today, then but naturally I can take up what is well known as a ground floor services plan with strategies for water harvesting. But before that, I would like to so levels, material and levels that is expected. So the schedule at the roof plan will actually talk about the roof covering that is there. Number of people show dotted girders. Okay. Number of people show the dotted girders. Some people show a part plan with the purlins that are there and the sheeting that is there. So some people show the roof in 3 parts. One is they show the position of the main trusses or the girders. then show the purlins on top of it and then the sheeting. If it's a flat slab, then there is nothing to worry. If it's a sloping slab, if it's an RCC slab, then all you need to give is levels and the slopes in which that are there. Please understand, I think I've spoken to you earlier, that such a big flat roof does not work. Okay. In case you are deciding to have such a big flat roof, then it makes sense. It makes sense that you are, then it makes sense that then it makes sense that that on the, that you break up the roof into a couple of parts. What I'm trying to say, that if I have a roof, if I have a slab that is as large as this, okay, if I have a slab that is as large as this, yeah, if I have a slab that is as large as this, in some sense, yeah, then the water tends to collect in the center and that would lead to leakages. In such points of time, it makes sense if you break up the roof. So part of the roof is higher, part of the roof is lower, so that this water drains off easily to these areas and then that drains off further below. So big flat roofs over auditoriums rarely help. Okay, it makes sense. Yeah, it makes sense. It makes sense that you break up the roof into a couple of parts. If you are thinking of putting a flat slabs, especially if it is a flat slab or a large roof, it makes sense that you break up the roof into a couple of parts such that you don't have large surfaces to drain off. You have smaller surfaces to drain off from one level to another. Yeah. So something like this, that you have a roof like that, and on top you have another maybe skylighted roof, breakup of a roof. This water slopes off and drops onto this. This water slopes off to that, and then it slopes off. So break up your roof. If you have flat roof, break up your roof as far as possible. That is there. Now today, what I'm trying to tell you is how do you make what is the kind of dimensioning and how do you do a good section which is different from a design section, and what is expected in a section as part of a working drawing, both section and elevation. I think that is a must because that is what is expected on the 8th along with your completed plans more or less you have seen, but in the sections it is important that certain things can't afford to go amiss. So first of all, if you do not have, but naturally I've talked number of times about a basement. Today I will not talk about a basement. Today I'll talk of a structure which is on the ground floor without a basement. Or I'm talking, even if you have a basement, I'll talk in either parts. I'll come to the basement a little later because I've spoken about the basement number of times. Suppose you have a ground floor. Then at the ground floor, usually you have what is called as a plinth beam. You have what is called as a plinth beam that is usually at the ground floor level. Okay. And you have a plinth beam at the ground floor level. And just a minute, let me. And then usually at the ground level, most beams are at the plinth level. Most beams are at the plinth. So that is what I'm trying to say, that usually internal plinth beams are higher and external plinth beams are lower. So this is an external plinth beam. Usually it is at the level of the ground, and that's the brickwork that is there on top. This is the brickwork on top, and these are plinth beams. Yeah, these are plinth beams that are there clearly. So this is the first thing that they will want to see. Yeah, whether in the section where we are able to see plinth beams or not. In the case of a basement, it will be different. In the case of a basement, what you will see is a retaining wall and a raft with a toe that goes there, and then but naturally layers of waterproofing that happen here, which the toe holds on to. Yeah. But actually it's a different, this is a different story in case if it's a, if it in case it's a basement. However, in case of usually this comes down and then you have what are called as a foot. And usually that ends with a footing. So plinth beams in the elevation, you usually see the column, the stagger of the column, the depth of the column and the footing. This is the detail. This is the first level of detail that is expected at the level of the section. Okay. Then, but naturally you will see all beams for all slabs, whatsoever slab that may be there. Okay. You will see all slabs with beams, proper beams. So there may be a beam here. There may be a beam here in coinciding with these beams that are there. Now you need to give two set of dimensions. The first set of dimensions is from the floor to floor height. That's this. You need to give the floor to floor heights. If there is a step down, whatever that may be there, you first need to give floor to floor height. The other you need to give is the beam bottom levels. That means you need to give this level. Need to give this level. Now, what's the reason for giving a beam bottom level? You need to understand that when I am concreting a column, I do not concrete the column all the way till the top of the slab. This column when did cast does not be cast all over till here. If I cast the column all the way till the top of the slab, in order to insert the beam, I will have to again break the column up to the beam bottom level. Hence, all working drawings clearly portray beam bottom levels such that contractors know to what level should they concrete the column and leave it there. So this is the level in which the column can afford to be concreted. Yeah, and that's why these beam bottom levels are usually given, thereby giving you an idea to what level the column needs to be concreted, such that you don't need to break into the column, because breaking into concrete columns causes more damage than good. So my first level of dimensions is the floor to floor heights that are there. But naturally there'll be various kind of heights. Suppose there is a step down here. But naturally my floor to floor height would reduce. Okay. Suppose there is a balcony that is there. But naturally this height. All these heights that are required from floor to floor need to be given. However, all beams require their beam bottom levels to be given. Okay, so this is a beam bottom. So if there is a column that is coming up from here, that is there, then one should know that this is the level at which the work needs to stop and this level needs to be given. And this is all in reference to 0, 0, plus minus 0, 0. So is this very clear to everybody that in sections, one is the floor to floor height that is to be given. The other is the beam bottom levels that has to be given. These are two expected areas that is there. Yeah. Along with seeing of all columns, preferably in elevation. What I mean to say is all these columns need to be seen in elevation. All columns need to be seen in elevation. Yeah. Then comes the rooftop, but naturally whatever be the rooftop, those height. So if there is any, suppose there is any peak, suppose there is any ridge, then what naturally those ridge details need to be given. That ridge height needs to be given so that the total height of the building is known. So if there is any ridge, any height that is there, yeah, that needs to be given. So I've given you an idea that floor to floor height, beam bottom levels, this is all that is expected, preferably in a well drawn technically right section. An elevation, on the other hand, will have, yeah, so not to forget that most people also put the center lines in place. That means so most of the center lines fall in place. So most center lines seen in plan also reflect in section. Yeah. Okay. Then come the elevations. Yeah. So is there any doubt in sections? Anybody has any doubt in sections? Yeah. Like I have not spoken with respect to the raft. Yeah. But with respect to the raft, again, the top of the raft to the top of the slab is the height that is to be given. But naturally the beam bottom of this slab that you are casting on the ground floor, that beam bottom of the level, that will actually say to what level is the retaining wall to be cast. Yeah, so the height of the retaining wall will not come right up to the floor. It will stop. It will preferably stop at the level where you want to cast the beam of the slab and allow the beam of the slab to integrate or merge along with the retaining wall. Is there any doubt by anybody? I do not know if people are there, sleeping, whatsoever that is there. Let's do a check. It's some of the people of my group only. That's the best way to check. Yeah, so my good friend Chirag, are you there, Chirag?
Yes, Jimmy, I'm here.
All clear?
Yeah.
Good to see you around. तुमने नाइट मारा था क्या कल के लिए?
Yeah.
तो अभी तुम जाग रहे हो? Good to see you. Good to see you. हाँ, Adesh there?
Yeah, Jimmy.
Yeah, good. So now you know how to make a good section that looks right. Are there any doubts in otherwise whatever has been shown to you?
No, Jimmy.
Good enough. Yeah. So now but naturally we will see what is expected in the elevations. But naturally, so I'll take a part elevation at this side.
Sorry, Jimmy, my mic wasn't working at the time. I have a doubt about sections. Am I
Yes,
audible?
tell me.
So, when we're talking about the section, do we have to show everything no matter how far it is in the building, or is there a certain distance up to which we show in a working drawing?
No, you don't need to show everything. You just see, when a person looks at the section, he should be in a position to understand the overall structural system that holds the section. If you show everything, it may perhaps become too confusing. But like I'll give you an idea. Okay. Like suppose I did show a beam, but I don't show its respective column that is a little further away. Okay. In elevation. Then it looks as if that beam is floating in air. Okay. I'll just give you an idea. Okay. Like you see a beam here. Suppose a beam is put in here. A plinth beam is put in here. However, you just show that without any reference, you just show that this is a line and things like that. And do not show the footing part of it. And sometimes it looks odd. Okay, sometimes it looks odd. So though the column and the footing may actually be in elevation and you are actually cutting through the plinth beam, however, sometimes it becomes necessary to show certain things in elevation. Like columns shown in elevation always helps for the person to understand at what level, at what distances the columns are. The columns also help you to state the center line and things like that. So what you're trying to say, and I try to understand, is not necessary that all aspects of the all aspects of the section need to be seen. Sometimes if you draw everything, it may become too confusing. So that's not true. Yeah, but show things that are structurally relevant in the section, preferably in close distance to the from where the section is cut. Am I clear?
Section of my first bay, I don't show a staircase that's all the way at my third bay.
Of course not. Of course not. Why will you show that? Of course not. Not at all. It will unnecessarily confuse the person from where you're actually cutting the section. So things like staircases and all that, no. All I'm saying is that structural members like columns, maybe lintels, maybe beams, if they are to be shown, then they could help in order to understand the overall structure of the building. Yeah, clear?
Crystal clear.
Yeah. Now with regards to elevation, what is expected in the elevation are the levels that are there very clearly. That means these levels are what are expected to be seen. And then, but actually, yeah, so this level, that level. All these levels are necessary to be seen in the elevation, but actually all those windows that are there, all those windows that you put, so window 1, window 2, window 2, all the window nomenclature that is there, the window and door schedule will also be seen. Simultaneously, you will see the door schedule, window schedule that is there. Yeah, and but actually the building specification that is there. Yeah, whatever is the building specification, you will write that. Whether this is exposed brick, yeah, or exposed form finish concrete. Yeah. So all these things, all the surface finishes will have to be given. All the window and door nomenclatures will have to be seen, and all the relevant details, be it beam bottom levels, floor levels, or peak roof details, they will have to be seen in the elevation. And the elevations will preferably be of all four sides. Yeah. The elevations will be of all four sides with all these four types of nomenclature. Yeah. Many people yet continue showing the show the center lines in the elevations. Yeah. Just superimpose the yeah, if not all across the building, but at least at the ends in order to show the references of the center line that are there. But that is left to you and your guide. Some guides are insistent on that. Some guides think that the center lines help the building more or less in plan and have very little role to play in sections and elevations. Is this clear to one and all? Yeah. If this is done, then we can get into another aspect of the detailing that is there. Should elevations and sections be clear for one and all to draw? Yeah. Gargi, are you there? Gargi, are you there? Sakshi, are you there?
Yes, Jimmy. Hi, I'm here.
Clear? Is section and elevation very clear to you? Should you be able
Yes.
to complete it for the 8th?
Yeah, definitely.
Good enough. Good enough. Yeah. Ria, are you there?
Yes, hi, I'm here.
Good enough. Clear? Is it all clear now for one and all to be in a position to draw out or detail out your sections and detail out your elevations? Should anybody have any doubt with regards to the, so one should feel free to ask, because the next topic I'm getting into is something more. Yeah, can we go ahead? Okay. So what I'm going to do next is, I'm going to share with you a couple of details, a couple of roof details in a couple of roof details in so to say section, because we are expected to detail out. We will soon be expected to detail out. Yeah, let's see. Let's see them. Okay. So now there are two types of details that you can preferably find when you work with roof sheeting. And most people are confused whether roof should be provided with gutters or not. Now, gutters work best when they are cast in situ, especially for RCC slabs. Like I'll give you an idea. Like if this is the kind of slab that comes down, and this is the kind of roof gutter that you see that coincides with the wall, with the thickness of the wall, thereby allowing you to create all kinds of, yeah. So suppose the wall thickness comes here, you have all kinds of a beam here. You can create recessed windows. You can put windows here, create recesses. All these kind of things that are there. In that sense, these kind of gutters work best when you have preferably slabs. Yeah, and that could be a beam here. Yeah, when you have slabs that end with a beam or a gutter beam, this is called as a gutter beam. Yeah. However, with metal sheeting, when we usually see that we try to give gutters, it tends not to work well. So in that sense, whenever we usually tend to flush off. We usually tend to flush off our metal sloping roofs along with the wall. Okay. So one is that I can allow suppose if this is a truss. Okay. So if I have purlins that sit here, and roof sheet that comes down. Okay, then usually you want the roof sheet to continue in a manner such that the wall that is there is offsetted and the water can drip off. Yeah. So you did not, it would be a wrong idea to give a gutter here, a hanging gutter like that. Yeah. It is not expected. Yeah. This is a bad detail in that sense. In that sense, this is a bad detail. It is best that you allow the roof sheet to come and go in line with that. Okay, so how do I go back? How do I go back? Back. Yeah. So that's the way of doing it. In some cases, between the wall and the facade, you have a gap. Suppose you have a gap here between the wall and the facade. Suppose you have a structure, you have a metal structure or an RCC structure, and you have a separate facade. Suppose you have a green facade. Okay, you have a green facade or a mesh facade. Okay, in such case, you can accommodate the gutter in between the truss. Okay, in between the truss and the roof sheet, and you can have a gutter that is hidden between the front facade and the building actually that is there, and you can take the pipeline and all that from in between. Are you getting what I'm trying to say? What I'm trying to say that in case you do not, if you want to hide a gutter, gutters are not something pleasant to be seen along the edge of the roof, especially if you have long overhangs. If you have long overhand, it makes sense that you allow the water to fall off. I usually, when I detail, I usually give long overhangs, give brackets, okay, to long overhangs, because long overhangs protect your building windows and all that extensively. And where the water is to fall off, I usually create channels in the ground. Okay, I usually create channels in the ground such that the water can be collected and drained off somewhere. So I do not give any gutters. I allow the water to fall off, and in order that soil erosion doesn't take place at the ground floor level, I usually give water channels, concrete channels, gratings, and things like that, so that water can be collected and it can go off. And but actually, when you have things like these, people at the ground level know that here there is water expected to fall off. So, you are careful, that is there. So I hope these three details are clear to you all. Yeah. If you have a metal roof, okay, if you have a metal roof, but actually, first of all, get your idea of the metal plate. So usually if it is a masonry wall, it starts with a concrete pad. Concrete pad has a metal plate. Metal plate allows you to bolt down the truss or whatever that is there onto the wall. Yeah. So suppose if this is your wall, concrete column or wall, whatever, this will be your plate, allowing you to bolt the truss onto that wall. And should you have a false wall or a false facade, then in between that you can always accommodate a gutter and allow the water to pass through from in between the walls that is there. I hope this is very clear to everybody. Gutter details are actually, so please understand, how is this project going to end? This project is going to end whereby you will cut sections through you will be in a position to detail out sections from various parts of your building. So suppose this is that's your stage, that's your this project is going to end by cutting appropriate sections from certain areas. Yeah, like a section through this. A section through the stage area, right from the basement to the stage, to the catwalk, to the roofing details all across. Maybe another section is cut from here. So this project is going to end with a couple of strip sections through your building, detailed strip sections. In the detailed strip section, but naturally you have to take a call on the member sizes, the connection details, the roofing details, the overlap details, yeah, finishing details, whatever that is there. Yeah, but this project is going to end with just a couple of cross sections that are there, nothing more than that. However, before that are a couple of services layouts that are expected out of you. Now, is the class clearly aware how to adopt what is well known as a water harvesting scheme? Is everybody aware of what is a water harvesting scheme, or has that been earlier taken? And would you be in a position to make a ground floor plan with all the three services in it? Yeah.
Fleur has a question. She raised her hand.
Oh, yes,
Yeah,
please.
Fleur. Go ahead.
I have a question from before. If we have like a facade outside, like a metal facade apart from like the wall, do we have to put like a sort of steel mesh between that so that people can walk for maintenance, or that's like we don't have to do that?
Like this one that I did show you.
Yeah.
Yeah, like this one that I did show you. Okay. Like Rahul Mehrotra has done a building in Hyderabad. where he has a green mesh on the outside of his building and he has walkways. These are all walkways. And gardeners can walk here. Gardeners can walk here, thereby, yeah. Gardeners can walk here, thereby curate, thereby, clipping the plants, watering the plants. Okay. And you could be sitting inside from the window, large window, and seeing actually what is happening on the outside. Are you getting what I'm saying?
Yeah.
So there can be metal bridges. There can be the floor can be extended out as lightweight metal bridges or floor extensions. There's nothing wrong. There is nothing wrong in this floor extending right outside. Nothing wrong. And that floor could actually support that outside mesh that is there. So have a look at this building that is done, commercial building in Hyderabad. If you type Rahul Mehrotra's office commercial building in Hyderabad, you will get this. He's applied this fundamental even in Europe, where he had to design a building amidst big architect giants. Yeah, big well-known renowned names who had all kinds of philosophies done in a farmers, if I'm not mistaken, a Pfizer on the borders of Switzerland. He was invited to do this building in the midst of Gehry and Hadid and McIntosh and yeah, all these well-known architects that are there. Yeah. And he played safe by just creating a green box and put it there. Yeah, where thereby his building act like a good buffer, it acted like a buffer. It acted like a sponge in the midst of all these heavy duty buildings that were there. So and then he's done this in Hyderabad, and there's some beautiful photographs. It shows that how an external uh, green facade can be accessed and can create its own biodiversity and ecology and flora fauna that can aid with the shading of the building, with the humidity levels of the building and things like that. Yeah, Fleur?
Yes, but if it's just like a plain metal facade, is it like a safety standard to have that, or can we not?
No. A metal facade is just a metal facade, though you don't need any walkway. All this cladding that you see usually has a framework behind that does not allow you to actually access anything behind that framework. No.
So if we were to attach it to the wall, which is which is recessed, we can like use brackets or something and attach that specific.
There are always like this ACP, which is known as aluminium, aluminium composite panels that you see on all these buildings, shiny metal and stuff like that. Usually there are brackets and there is a framework created onto which you can either fix glass, you can either fix metal. The companies that fix glass also fix metal, right? Depending on where you want an opening, you could have a fixed glass, or depending upon where you want you could have fixed metal, right? And for that, you don't need access anywhere and everywhere behind it.
All right, thank you.
Yeah. So, Shravan and Fleur and gang, are you all aware of how a water harvesting layout is to be made if it is to be incorporated on the ground floor plan of this building? Have you all earlier done water harvesting? By any chance, are you all aware what are the various techniques of doing, 3 techniques of doing water harvesting? Or do you think you will be in a position to manage a ground floor plan with all aspects of water harvesting that is there?
So wait, when you say 3 methods, do you mean 3 methods on the ground floor or 3 methods overall?
Overall, there are 3 or 4 ways to go about.
One is from the terrace, you collect it into the gutter and then it flows down in the pipes. And those pipes can be ornately decorated if you want. One is when you have a soak pit on the ground and then a collection pit where you have the pebbles and then the pipe is under that layer of gravel and smooth pebbles and sand. There's a filtration layer which I don't remember off the top of my head. Uh, Third is groundwater recharge and then the bore well.
So
Or-
one needs to understand, as he rightly said, I do not know if everybody is aware of that. There are three ways actually to use to make what is called as a water harvesting plan. One is that the roof water that comes down is the cleanest of the lot. And it makes sense that you directly tap that. Okay. So it makes sense that any water that you collect along the rooftop, you are able to directly divert it to an underground water tank, which is well known as a water harvesting tank or a flushing tank, such that that water can be used during the monsoon months for flushing, watering plants, whatever, all ancillary activities that are there. So roof water preferably should be collected and stored in a water harvesting tank that also acts as a subsidiary flushing water tank. In the non-monsoon months, that same thing will, because you don't have any rainwater coming down your roof, you will have a bore well on your site, and that bore well will send the water to the flushing tank on your upper floor, that is your terrace level, to serve water during non-monsoon months. So I hope I have answered I hope everybody is now clear that during monsoon months, water from the roof is used in a flushing tank on the ground floor or a water harvesting tank on the ground floor, which also serves water for flushing during the monsoon months. Non-monsoon months, you will have to show a pipeline from what you can consider as a bore well. And from that bore well, you can allow that water from the bore well to go directly to your top flushing water tank to supply water to your toilets. This is the first way of doing water harvesting from the roof and meeting the needs of your flushing water capacity. I hope everybody is clear about this. Any doubt? Anybody has any doubt? Second strategy is that when there is a heavy shower, usually water floods on your site. Okay. So if there is a heavy shower, the water that falls on your ground floor, on your site, usually tends to flood, and usually you tend to allow that water to get out, okay, into the municipal gutter or something like that. You can divert that water into what is called as a soak pit. So you can assign on your lowest part of your site what is called as a soak pit. A soak pit is a large tank that is not made out of impervious, that is not made out of concrete, or it allows the water to soak in. All that the soak pit does is hold your water after the heavy shower for a good 40 minutes or so, and allows that water to get into the ground slowly and steadily, thereby increasing the water table level. So this is strategy number 2. Strategy number 2 is that you collect as much as water from your site and channelize it to a underground soak pit. What does a soak pit mean? That means its walls are made out of gapped masonry. That means the masonry work is done in such a manner that there are holes in the walls of the tank. The floor is not done in concrete. The floor is completely impervious, pervious, allows the water to soak in. The only thing is that it holds the water when the heavy shower is happening. It does not allow your site to flood. And more important of all, after the shower stops, for an hour or so, it allows the water to slowly and steadily sink into the ground. This is strategy number 2. Strategy number 3 is what is called as, why did I forget that? Trenches. So strategy number 3 is trenches. What are trenches? Usually the periphery of our plot is lower than the center of our plot. Usually we do that. We usually keep the peripheries of our plot lower because that you try to match the road level, and the center of the plot you tend to raise high by doing, yeah. So the peripheries of the plot are usually kept low, and water collects usually along the peripheries of the plot. In such times, a little away from your boundary wall, you dig deep trenches. Trenches are long pits, thin long pits dug parallelly to the boundary wall, away from the boundary wall, because these trenches can badly destabilize your boundary walls. You do not want to destabilize your boundary walls. You want your boundary wall, you don't want to get a water harvesting system in place that breaks down your boundary wall. Making boundary walls is an expensive ordeal. So little away, 2 feet, 3 feet away from the boundary wall, you dig these 2 feet wide trenches. These trenches go deep into the ground, 3 feet, 4 feet below the ground, and are filled with rocks. What happens is that this rainwater that usually slopes along the periphery of the site, slowly and steadily that water enters into the ground. So you have three strategies. The first one is whereby you have a water harvesting tank, proper tank that holds water. And you can actually decide how much water you want to hold for flushing criteria, whether for 1 week, 1 month. It all depends upon how large the tank you made and how much water you are able to collect out of your terrace. There's a calculation, you can do that. You can refer and you will find such calculations of water harvesting for water harvesting tanks are easily available. The second is by making a soak pit, whereby you collect the water for a good hour and allow it to go down. And the third is linear trenches along the periphery, whereby all water that collects along the periphery of the plot slowly and steadily enters below the ground. Are the three strategies very clear to everybody? Because you will have to adopt them in a ground floor services plan along with water supply lines and drainage lines. Anybody has any doubt of what I just said? Because I just spoke about it. I know you all have had a long day, and I would also like to end the class as soon as possible. As it is lost more than half an hour in trying to connect, and I'm sure that has added to your frustration level. I somehow find connecting from home is easier than coming to college and trying to connect from college. However, you know, this board where you can sketch easily is easily available in college, and so it's easy, and we are used to sketching on big boards, so that helps in some way. However, should you have any doubts, feel free to ask. Should you not have doubts, then we can call it an easy day. But are the three strategies for water harvesting to be in a position to draw out in your drawings clear to everybody? Anybody, any doubt? Sejal, are you there by any chance? Sejal? Rati, by any chance, are you there? Wow. Rati, Sejal, what is the class attendance dropping badly?
It's 60 as of now. It was
No issue.
65 when we started. Yeah.
No issue. No issue. So Rati and Sejal, are you there by any chance? My good friend Sahil the CR, are you there?
Yes, I'm here.
Sahil, by any chance, have you all understood the three strategies for water harvesting? Is it easy
Yes.
to understand? Would you be in a
Yes.
position to draw it out if you had to draw it on your ground floor plan?
Yes, I can give it a try now.
You should give it. I think everybody should give it a try for either tomorrow or next class, because I'm sure all the faculty know of how to implement. And let me tell you, to work in Mumbai, you are bound to have a water harvesting plan. It's a requirement by the BMC to get permission for completion of building. Should you not have a water harvesting strategy for your complex or for your building, you do not get occupation certificate. Yeah. So it is a must for everybody, and it is a must. You know, we have so many flooding issues in our city. Should we all be able to manage our rainwater on our individual plots? We should not create all these problems of flooding and pumping water out into the sea and stuff like that. Should we all be able to manage our site waters well? So if it is very clear, yeah, do you think Fleur, Shravan, yeah, Chirag, do you think it is very clear and it is possible for you to at least attempt water harvesting strategies on the ground floor plan?
Yes.
Yes, we can attempt.
Yeah.
Jimmy, I had a question.
Uh,
If I have a rooftop garden, uska runoff I'll take as a terrace runoff, right? Like there will be
Yes.
some runoff, obviously. So
Only
that
thing
will
is
work.
that the runoff will be, see, on a terrace, the runoff is as good as 95%, right? There's a percentage of the runoff you usually consider. In your roof garden, your runoff will be as good as what? 60-70%. Some of your water will get absorbed in your rooftop, right?
And that can only be used for the gardening purposes, right? Because it's not potable after it's been through the
Not
soil.
necessary, not necessary. Usually all water that you collect in your underground tank always has a filter. So water will pass
For
through
flushing or gardening.
yeah, so your water will always pass through a filter, sand filter, and the sand filter will hold on to any of the mud or organic material that comes down from your roof garden. Clear? Anybody else? Anybody else? Any doubts with regards to implementing of water harvesting plans that are there? I hope it is all very clear now that you should be in a position to complete all floor plans, sections and elevations for the 8th, along with the superstructure of the BOQ that Neeraj has taken up last time. May I advise you that for the coming Saturday, Sunday, you please devote one day. Yeah, now that your design jury is done with, you please either allocate a Friday, Saturday, Sunday or Monday, any of these 4 days or at least 2 days of the 4 days for your submission on the 8th, because the marking on the 8th is pretty large. I think if it's not mistaken, it is more than 40 marks of marking. It is asking guides to look at all aspects of plan completion. It is expecting all aspects of sections, elevations, and a BOQ of the entire superstructure. Yeah. Next time in class, if we want, we can actually, Neeraj, if possible, can we count the number of element items they should be actually taking up for superstructure? Because up to the ground floor, most people had 12 items. If we are also able to finalize that, how many columns, brickwork, plaster, door, window, whatever that may be there as part of superstructure. If we are able to identify the items, then the students know, that
Total
these
this
are the
many
number of
items.
items that they have to attempt. If possible, next time's class, we can actually help students finish off their BOQ such that, such that they can be relieved and have to work only on the drawing for the Wednesday.
Okay. Yeah, that works.
Till then, if there are no doubts, we can call it a day. You'd like to add anything, Neeraj, or we can then call it a day?
No, yeah,
Thank you,
I guess
everybody.
that's pretty much. Thanks, Jimmy.
Thank you. Thank you.